Hello, I'm Heather Kelly, and the field crops plant pathologist with the University of Tennessee, and with me is my PhD student, Anna McLaughlin. We're going to be talking about identifying corn ear rots and managing mycotoxins.
So what are corn ear rots? Corn ear rots are actually diseases that are caused by a few different fungi that actually colonize the ears or the kernels on the ears, just like the name states, and breaks down these kernels, causing them to lead to poor bearing quality, lower test weights, and then maybe also mycotoxin contamination. Today, before we go over the ID and management of some of these significant ear rots in Tennessee, I would actually like to point out our pest triangle, which is the 4 different categories right here that must be present for these diseases to develop. Really in corn ear rots, so we're going to start with pathogen. The pathogen is the causal agent for the disease. In this case, this is going to be the fungi that causes our ear rots. This could be an inoculum in your field or something that's blowing in. And then 2, you need a susceptible host. This is, in this case, is actually corn, susceptible to a few different pathogens that cause disease. And then the 2 really important legs in this triangle right now is, especially for ear rots, is your time and your environment. So your timing, these ear rots occur at or a little bit after R1. So this is our silking. Yeah, we've got it. R1 is in this presentation highlighted in red. And you can see the silks up in the right-hand corner. So timing for these ear rots happen around this time. And then, but whatever ear rot you're going to get really depends on your environment. So with your environment, this must be the environment that is around this timing in order to cause these different kinds of ear rot disease. Thanks. So what are mycotoxins and what do they do and why do they matter? Mycotoxins are toxic secondary metabolites that are produced by fungi. These compounds are very difficult to eliminate due to their molecular stability, not easily broken down. That being said, not all ear rots actually produce mycotoxins. Though some of these fungi that do produce mycotoxins, like the 3 that I've kind of highlighted on the screen today, are aflatoxins, our vomitoxins, and our DON. These are 3 of our big toxins that is actually going to be, the FDA actually has advisory or set guidelines for. So that being said, there's only advisory threshold for, sorry.
Advisory thresholds
right.
For fumonisins and vomitoxins, in which the advisory levels are those that are believed to be adequate margins of safety. Action thresholds are those that are very set in stone and will be backed up by the FDA because it is a precise level of contaminant of a known carcinogen, where fumonisins are, there are data out there, but not as strong as for aflatoxins. So aflatoxins, they are the strong action thresholds, which are produced by Aspergillus species that are the known carcinogens, where fumonisins can also be a carcinogen, but only have an advisory threshold. And then vomitoxins, as the name sounds, it actually isn't a known carcinogen, but in animal feeds and such will make them regurgitate.
So here's an overview of some of the more common ear rots or significant ear rots that I'm going to go over a little more in depth today that we're going to be going over. So we have Aspergillus ear rot, Fusarium ear rot, Gibberella ear rot, and Diplodia ear rot. And so the first one on our list is our Aspergillus ear rot, and this is the one that I kind of like to call our hot rot. It's Aspergillus, caused by Aspergillus species. So our symptoms are actually yellow to olive green patches of spore. They're going to be very grainy. These are going to be seen in and between kernels, and it's usually seen at the very tip of the ear. So the favorable conditions, like I talked to you about, I just said the hot rot. Aspergillus really likes hot temperatures above 85, 86 degrees, and is really more severe during drought conditions. And so things that contribute to Aspergillus ear rot would be sandy soils, things that cause plant stress, insect feeding. You can see actually in this photo here on the left, you can see that this is actually following insect damage, that our Aspergillus ear rot is following probably a borer damaged here. So Aspergillus ear rot actually produces aflatoxin. That's its mycotoxin. It's highly toxic to humans and animals. It's a known carcinogen. And this is what we were talking about. The FDA has an action threshold for aflatoxin. There's actually, when we're talking about yield penalties for Aspergillus ear rot, this can be associated with drought, or is usually associated with drought. And it's very difficult to estimate the actual damage by the disease. Aspergillus ear rot, the fungus itself, can reduce kernel weight, which can have an impact on yield. But really more concerningly would be the aflatoxin that's produced, because this affects grain quality and marketability, mainly through that FDA action threshold. And here on the right, you can actually see the action thresholds for aflatoxins, and this is going to be in parts per billion. This is the only toxin that is in parts per billion. The rest is going to be in parts per million. So the best management for ear rots really starts prior to planting, because little can be done to protect ears after infection and prior to post-harvest strategies. Things that you can do if you've had aflatoxin last year or plan on planting corn again this year is to start with your hybrid selection. Currently, there are no commercial hybrids that are resistant to Aspergillus infection. There are some hybrids available that have tolerance to ear rots. The next two strategies that we're going to get into, I know is it's hard to manage stress, but it's things that we have to talk about. So the two strategies for reducing stress is you want to be looking at correct soil fertility and your timely nitrogen applications, as well as irrigation, and then also managing your insect damage, and then thinking about just not only insect damage, you want to be managing your weeds and your other plant pathogens that may infect corn as well, because all of this contributes to plant stress, which will exacerbate the disease, Aspergillus ear rot, and really ear rots in general. So two other things that field management wise, that's sometimes plausible that we can do. You might want to avoid continuous corn. And then also if we can till up that field and get that inoculum broken up for that year. Those are also other strategies for management. Another strategy is actually there's one product on the market right now, biological control called AlphaGuard. This is a non-aflatoxigenic strain of Aspergillus that actually out-competes toxic strains in the field. This is usually applied at B10, and it's actually, it's going to be on a seed, and you're going to usually by aerial application is how you would apply this. But there also has been an actual spreader that you put on the back of your tractor that's been used for spreading alpha guard. Fusarium ear rot is caused by a few different Fusarium species, and this is one of two that we'll be talking about today. So this is the most common species that are usually associated with this Fusarium ear rot is Verticillium and Proliferatum. Fusarium ear rot is more common year to year in Tennessee because the conditions are more favorable, and because it really has a wide range of environments that it can be adaptable to. But it's more severe in high temperatures above 77, though it likes a little more moisture than our hot dry rot Aspergillus. For symptoms of this disease, you get a cottony whites, about a peach to purple mold that will be randomly distributed on the ears all over the kernels. And infected kernels can be brown, and then also they'll have like a streak, which is more known as the starburst pattern. It almost looks like something has scraped the ear, and you can see we've magnified the starburst pattern under the first picture. So the mycotoxins associated with fumonisin ear rot are known as, Fusarium ear rot are known as fumonisins, which are toxic to animals. It really toxic, extremely toxic to horses and swine. So fumonisin has also been linked to increasing cancer rates and other human health problems. However, the evidence is still debatable. It's a suspected carcinogen is what we would really call it right now. With that, the FDA has set advisory thresholds based on intended use. Once again, we've got them highlighted right here. Like Aspergillus ear rot, the yield penalty for Fusarium ear rot Fusarium ear rot is more often due to mycotoxin produced by the Fusarium species rather than the fungus itself. So hybrid selection for Fusarium ear rot differs a bit from Aspergillus ear rot. Once again, there's not a commercially available hybrid that is Fusarium ear rot resistance, but there are hybrids that have tolerance to Fusarium ear rot. You can check that on when you're looking for to buy your seed. So selecting a BT hybrid that gives protection from ear feeding insects is also a good option for Fusarium ear rot. I'm saying this mainly because there's been more data that it's more connected, unlike our Aspergillus ear rot, which is very variable in its response to BT hybrids and BT hybrid insect protection and its effect on aflatoxin. So added to the field management section is crop rotation, particularly soybean and cotton. Rotating one of these crops with corn will help reduce the overall inoculum, not just the ear rot pathogens, but also there's many other pathogens that can be affecting your corn, which can, once again, like I said, exacerbate disease and your ear rots. Just keep in mind that when you're rotating, these pathogens can be a seedling disease to cotton and soybeans. So a seed treatment in fields with high occurrence of ear rot may be recommended. Once again, plant stresses is our big deal when you're talking about ear rots. You want to manage plant stress as much as possible. Though drought is an ideal condition for Fusarium ear rot. Fusarium ear rot and fumonisins still occur in irrigated corn.
So switching to another ear rot, Givarella ear rot, it's also caused by Fusarium, but specifically Fusarium graminearum species. And so with this, the symptoms are different. For the most part, you see this more at the tip, and it's reddish mold that you'll see at the tip. that then can grow down the ear. And so where this ear rot develops, the husk usually tightly adheres to the ear due to that pinkish fungal growth that you see. And we'll talk a little bit more about this in some other slides, but this pathogen can also cause some other issues in corn, including stalk rots. And so pictured on the very far right is the red discoloration by the pathogen in the stalk. So this pathogen and this ear rot develops more severely under cool, wet conditions, again, that are occurring after that silking stage. Because the spores infect through the silks, and then infection then can continue to develop under the right conditions up until and after R6, and until grain moisture is below 18%. So gibber ear rot does produce and can produce a mycotoxin called vomitoxin, as well as a secondary mycotoxin. And for short, vomitoxin is also referred to as DAWN. And this is the same mycotoxin that we are concerned with in Fusarium head blight or head scab. So here, animals may refuse to consume and regurgitate grains with this vomitoxin or DAWN, and it can also cause infertility and abortion among animals, along with other breeding issues. So definitely a high issue in feed for animals who are for breeding purposes. So on the right, as before, you see our different FDA advisory thresholds for the DAWN in grain. And again, this is in parts per million. Similar to our other ear rots, the yield penalty is not only a reduction in the weight of the grain and dry matter, but also due to the limitations if it is contaminated with the DAWN. So management for Gibberella ear rot, again, a lot of the same ones for the other previous ear rots. There is some hybrid selection. You can look at less susceptible hybrids, as well as then your field management. And so again, avoiding continuous corn, as well as where applicable, if previous debris can be tilled in to help it to deteriorate more quickly. And then here with crop rotation, again, it's recommended soybean or cotton, although again, sometimes these Fusarium species can be seedling diseases in soybean or cotton. Here, the big thing is, again, how I mentioned earlier, the same pathogen is what causes head scab in wheat. So pictured on the very far right is some wheat heads affected by head scab. And so this is also why sometimes you might not see the issue in your corn, but when you plant wheat after corn, you actually have an increased risk for head scab or head blight in wheat, which again, one of the bigger things is that contamination with the vomitoxin or DAWN. And lastly, reducing plant stress, as with all the other ones, as we've mentioned. The healthier and stronger the plant is, the better it's able to kind of fight off ear rots, as well as just not allow them to colonize the ear. The last major ear rot that we're going to talk about is Diploidea ear rot. Here, there's two different species that have been found to cause ear rots in Tennessee. Symptoms would be bleached husks, seen on the far right, where the rest of the plant will still be green. When pulling back that husk, looking at the kernels, they're dull gray to brown with then white to grayish fungal growth on and between the kernels. And this usually starts at the base of the ear. And then also on the next slide, I'll show you, on the next slide, you can see when you break a ear in half, you might see black pycnidia, which look like someone shook a pepper shaker over it, which you would see those later in the season. Here again, it's more wet conditions that favor this ear rot, as well as delayed harvest can promote severe epidemics. Bird and insect damage also predispose plants to these infections. But it is nice, at least for this ear rot, it is not associated with a mycotoxin. So here it's mainly the damage that the ear rot causes to the ear that we are and the kernels that we're concerned with. Again, due to that ear rot, you can have lighter weight kernels, reduced nutritional value, which also just means more cobs and kernels can be ground up during the combining process, having a higher level of broken and foreign material in the bin. And again, over on the very far right, you're seeing those black pycnidia when you break open an ear in half to look for that. So again, management for Diplodia ear rot, that selection again, avoiding continuous corn tillage when possible, again, crop rotation to soybean or cotton, and reducing plant stress. Here I do want to mention, so Diplodia ear rot, the same pathogens you can see them causing sometimes Diplodia leaf streak on the leaves, pictured on the right, and a stalk rot, Diplodia stalk rot. But just because you see one of these doesn't mean you will actually see ear rot. Even though they are the same pathogen, we have been seeing more Diplodia leaf streak lesions the last few years in Tennessee, but we have not associated that with an increased rate of Diplodia ear rot. So with this is a summary table. This same summary table can be found on our UT Extension Managing Ear Rots and Mycotoxins publication. So here again, you'll want to start scouting. We've been talking about pre-harvest and pre-planting management. But here there are some things, once you find a field and you've identified what ear rot you have in there, there's some things you can do post-harvest or getting ready to harvest to know. And so that's where, if you do find a field out of many fields that has a certain ear rot that will have the possibility of producing mycotoxins, you want to segregate that grain to avoid contamination of mixing non-infected with infected grain. And also when you are trying to salvage grain that has ear rots in it and possibly mycotoxins, you can target those fields to harvest them first and then dry them within 48 hours down to at least 15% moisture. That stops the pathogen from continuing to make any mycotoxins. It won't reduce what was already there, but it will stop it from producing any more. And for long-term storage, it needs to be down to 13% moisture. So again, the summary of preventative management of ear rots is critical. So again, your hybrid selection, reducing corn residue, whether that's tillage or just rotation to non-hosts, and reducing plant stress any way you can. And again, on the right, the chart to review the 4 major ear rots that we've gone over. Aspergillus ear rot, you have yellow to olive green spores. It likes it hot, the hot rot, if you will. And usually it's occurring on the top of the ear, and it does produce mycotoxins called aflatoxins. Diplodia ear rot, white mold to grayish brown, and then dry weather, but followed by wet conditions. And here you usually see this at the base or the bottom of the ear, but it does not produce any mycotoxins. Fusarium ear rot, you have white to kind of purplish cottony mold. It's most severe under high temperatures and some drought stress. Individual or group of kernels of ears is where you will find the pathogen, and it does produce fumonisins, the mycotoxin. And then last on our table is gibberella ear rot. You can find pink to reddish mold. It's most severe under cool and wet conditions after R1, and you usually can see it on the top of the ear, and here it also produces mycotoxins.
And so I'm just gonna go over briefly some of our minor or less common ear rots that also occur here in Tennessee, just not usually associated with either mycotoxin or yield loss. We don't really see them as much. So penicillin ear rot is caused by penicillium species. Very high humidity is what it will like in the field. Symptoms develop like a powdery blue. Be careful here between this one and trichoderma. Sometimes really looks like Aspergillus ear rot late in the season. Penicillium is usually a more troublesome disease when it's actually in storage. You might have heard the term blue eye. This is when the mold actually grows underneath the skin of the kernel, and it's called the blue eye, kernel embryo. So then, and it's also usually associated with ochratoxins. However, there are no FDA guidelines available for this right now. And then trichoderma, this is a more vivid green than our aspergillus, and it's usually spread all the way up and down the ear, caused by trichoderma species. It really likes warm temperatures followed by a lot of rain. And then Nigrospora ear rot, the pathogen causing by Nigrospora oryzae. Really brought on by drought conditions, and this is a very, you can't really tell this disease until really late in the season. You get dark gray to black mold in between the kernels, and then you can kind of get small black fungal spores on the ear surface. However, with this one, compared to the major ear rot we talked about with the Plodia, you can actually wipe these spores away from that surface. Once again, it's similar in appearance to diplodia. And then, so abnormal ear symptoms, which are not rots. We've got our kernel red streak. This is actually caused by a mite. It's a secretion, it's a toxin that isn't toxic to human or animal. It's just a phytotoxin. But you get that, it almost looks like that starburst pattern that we called, or it kind of looks like a lifesaver candy. Not much to worry about, and usually more common after wheat. And then your corn smut, this is caused by Euslago matus, and it's a kind of not a rot, but something we see a lot in our fields. It can help other rots develop, but it's not usually a big issue in the fields.
So wrapping up our presentation, we want to highlight some of the resources online available to you, as well with our guide site, guide.utcrops.com, images and pictures of diseases, and not only ear rots, but other diseases across our major field crops can be found, as well as insects. And then news.utcrops.com. You can subscribe to weekly emails or just visit it as you want to, but this is in season, kind of real-time updates from our field crop specialists here in West Tennessee to let you know what you might need to be on the lookout for or for planning ahead. And then to know your variety, search.utcrops.com is our variety database for all of our major field crops. All of the UT data that is collected on varieties can be found there. And then lastly, utcrops.com really is the one that you only need to remember. You can get to all the other websites from utcrops.com, as well as finding additional publications and fact sheets on this website. And as always, contact your county agent for additional help in identification of ear rots or other management issues. And with that, we'd like to thank you for your attention. If you'd like to follow up with us, if you have any questions or need any additional guidance, you can email us. And if you are on Twitter, you can follow us.